Take a look at a typical city street at night. On one side, you have a safe, highly visible corridor. On the other, a burnt-out bulb leaves the street plunged into darkness. Keeping those streets illuminated is one of the heaviest financial burdens a local government carries. Powering and replacing thousands of high-wattage bulbs devours a massive percentage of a municipality's annual energy budget. The real issue lies in how legacy grids operate. They are entirely passive. A traditional street lamp cannot communicate that it's broken. City administrators learn a bulb has died only when a resident complains or a maintenance crew happens to drive past it. Because maintenance relies on this reactive, manual reporting, neighborhoods can be left with unlit blind spots that persist for days. This lack of monitoring forces cities to spend taxpayer money on inefficient power usage while leaving public safety to chance. The city of Padang Panjang faced these exact physical and financial bottlenecks. To address this, they formed a strategic partnership with PT Developer Technology Indonesia to overhaul how the city handles its public infrastructure. They converted the entire physical lighting grid into an interconnected digital network. Solving modern urban problems requires systemic intelligence. Padang Panjang chose to fix the grid by integrating it with a centralized digital brain. The solution they deployed is called Smart PJU, the System Penerangan Jalan Umum Pintar, or Smart Public Street Lighting System. The core mechanism driving this upgrade is that it is berbasis IoT, meaning it operates on the Internet of Things. Physical objects connect to the Internet to send and receive data. Equipping a street pole with environmental sensors turns it into an active data node that constantly reports its status. When scaled, hundreds of these nodes link together. They form a continuous, live-streaming data network stretching across the municipality. In an IoT framework, the light emitted by the bulb is a byproduct of the operational data the pole generates. All of that live data feeds into a central command dashboard. City administrators now monitor the status of their entire infrastructure from a single screen. This interface shows the network scale. Out of 1,248 lamps, 1,198 are online. For offline units, automated alarms immediately provide exact GPS coordinates, eliminating physical patrols. It also allows remote control, dimming sectors based on conditions. This resulted in a 32.6% energy reduction. Converting physical infrastructure into a digital dashboard turns real-time visibility into tangible resource conservation. When we step away from the software interface and look at the actual streets of Padang Panjang, those data points translate into physical outcomes. Slashing energy consumption by nearly a third shrinks the city's carbon footprint and overall emissions. On an operational level, instant failure detection means maintenance crews are dispatched with pinpoint accuracy. Neighborhoods remain consistently lit because downtime is measured in hours rather than weeks. The system provides 4 core essential benefits: energy saving, safe and monitored status, efficient and optimal operations, and eco-friendly outcomes. These pillars serve as the baseline requirements for a sustainable urban environment. Building a smart city is often associated with futuristic architecture or massive construction projects. Padang Panjang bypassed those theoretical concepts. They solved complex municipal challenges by upgrading an everyday asset that already existed on every block. The true foundational layer of a smart city begins simply by bringing the most basic public infrastructure under digital control. Smart PJU integrates real-time software monitoring with physical city hardware to manage municipal resources more effectively.